Betelgeuse, also known as Betelgeuse, is a red giant star located in the constellation Orion. It is one of the largest and most luminous stars known, significantly larger than our Sun. To give you an idea of its size, if Betelgeuse were placed where the Sun is, it would extend out to the orbit of Jupiter. This makes Betelgeuse an enormous and very unstable star, on the verge of exploding. It is one of the most significant sources of energy in the universe, producing more energy than a billion suns. Despite its size and instability, Betelgeuse has intrigued scientists for years, but recent developments have made its future seem even more concerning. When we think of stars, we might picture tiny, shiny objects in the night sky. This is how they appear from Earth, but in reality, stars are much more complex. Betelgeuse is a prime example of this complexity. Discovered by the Greek astronomer Ptolemy, Betelgeuse is so large that it can be seen in the night sky from Earth, especially during winter. It marks the upper left shoulder of the Orion constellation. As one of the brightest stars in the night sky, Betelgeuse has been studied extensively. Its brightness, however, is not constant. It fluctuates due to its unique properties. Most stars we see are very far from Earth. The nearest star, Proxima Centauri, is about 4.2 light-years away. A light-year is the distance light travels in a year, which is about 186,000 miles per second. In a year, light covers a distance of approximately 5.88 trillion miles. Thus, when we say the nearest star is 4.2 light-years away, it means it is about 24 trillion miles from Earth. Betelgeuse is located approximately 600 light-years away from Earth. If you were traveling at the speed of light, it would take 600 years to reach Betelgeuse. Despite this immense distance, Betelgeuse shines brightly in our sky because of its enormous size and brightness. Betelgeuse is about 500 times larger than our Sun, with a radius around 1,000 times that of the Sun. Its immense size makes it appear as a disk in space when viewed through sophisticated telescopes, unlike other stars that appear as tiny points of light. This appearance is suspected to be due to reactions in its outer atmosphere. In terms of mass, Betelgeuse is estimated to be between 12 and 19 solar masses. A solar mass is a standard unit of mass used by astronomers, equal to 2 times 1032 times 1030 kilograms. Although scientists cannot determine the exact mass of Betelgeuse due to the lack of planetary bodies orbiting it for comparison, it is known to be at least 12 times heavier than our Sun. The brightness of Betelgeuse varies from magnitude 0 to 1.6. To put this in perspective, Betelgeuse can be up to 16,000 times brighter than the Sun. This variability is due to its pulsations. Betelgeuse expands and contracts, which causes its brightness to change over periods of 10 to 100 days or more. Another unique property of Betelgeuse is that its surface is covered in dark magnetic spots. These regions have a much stronger magnetic field than the rest of the star, inhibiting the flow of hot gas to the surface and making those areas cooler. The numerous and large magnetic spots on Betelgeuse, which can be twice as large as Earth, explain why it is cooler than our Sun despite its size and brightness. Betelgeuse also has a magnetic field about 1,000 times stronger than that of the Sun, causing the gases on its surface to appear in loops or arcs when viewed through a telescope. Its surface temperature is about 3,500 Kelvin, which contributes to its low energy output and red color. Betelgeuse wasn't always red. It was yellowish about 2 million years ago, similar to our Sun. Over time, its color changed to orange-red and then to the red star we see today. This color change suggests that Betelgeuse is aging. Betelgeuse emits up to 7,500 times more energy than the Sun. If it were closer to Earth, we would be able to see it during the day. However, due to its distance, it would displace Earth and the 4 other inner planets if it replaced the Sun. Furthermore, it emits more radiation than our Sun, known as a supergiant star. Betelgeuse is located in the constellation Orion and is approximately 600 light-years away from Earth. Its immense size, about 500 times larger than our Sun, would easily encompass the orbit of Jupiter if it were placed at the center of our solar system. Despite this size, Betelgeuse is not the most massive star, with an estimated mass of 12 to 19 times that of the Sun. The brightness of Betelgeuse fluctuates regularly, ranging from magnitude 0 to 1.6. At its brightest, Betelgeuse can be 16,000 times brighter than the Sun. This variability is due to its pulsations, with the star expanding and contracting, causing its brightness to change. The surface temperature of Betelgeuse is relatively low, around 3,500 Kelvin, giving it a reddish-orange hue characteristic of red giants. As a red giant, Betelgeuse is in the late stages of stellar evolution, having exhausted the hydrogen fuel in its core and begun fusing heavier elements, which causes it to expand. Betelgeuse's atmosphere is a fascinating aspect of its study. It is rich with complex physical phenomena, including dark magnetic spots that are larger and more numerous than those on our Sun. These spots inhibit the flow of hot gases to the star's surface, resulting in cooler regions. Betelgeuse has been observed and documented throughout history, playing a significant role in various cultures and mythologies. Its visibility in the night sky has made it a prominent feature in constellations and folklore. In recent years, Betelgeuse has gained increased scientific attention due to its dimming episodes, which began in late 2019 and continued into early 2021. During these periods, the star's brightness dropped to unprecedented levels, sparking speculation about its potential to go supernova. Subsequent observations suggested that the dimming might have been caused by material ejection and the formation of a dust cloud that temporarily obscured its light. Despite this, Betelgeuse remains a key candidate for a nearby supernova event, which, when it occurs, will be visible from Earth even in daylight. Betelgeuse's environment is characterized by a vastly extended atmosphere and complex interactions between the star's magnetic field and its material. Red supergiants like Betelgeuse are in the late stages of stellar evolution, eventually shedding their outer layers and forming a planetary nebula. The remaining core may collapse into a neutron star or black hole, depending on its mass. Betelgeuse's eventual collapse will be one of the most spectacular events in the universe. Observing red supergiants like Betelgeuse presents challenges due to their immense size and brightness. Advanced observational techniques, such as interferometry and space telescopes like Hubble and the James Webb Space Telescope, JWST, are crucial for studying these stars. JWST's advanced infrared capabilities are expected to provide unprecedented views of Betelgeuse and other distant stars, enhancing our understanding of massive stars and their role in the universe. Betelgeuse plays a vital role in understanding stellar evolution. By studying such massive and relatively nearby stars, scientists gain insights into the life cycles of stars and the processes that lead to their ultimate demise. Research on Betelgeuse helps refine models of stellar evolution and provides valuable data on the triggers of dramatic end-of-life events. As one of the most luminous stars in our galaxy, Betelgeuse influences its surrounding environment through intense radiation and stellar winds. These winds contribute to the formation of new stars by compressing the surrounding gas and dust. Additionally, Betelgeuse's eventual supernova explosion will enrich the interstellar medium with heavy elements, contributing to the formation of new stars and planetary systems. Betelgeuse's historical and cultural impact is notable. Its prominent position in the Orion constellation has made it an important feature in the mythology and folklore of many civilizations. In ancient times, Betelgeuse was used for celestial navigation and calendar systems. Its bright reddish hue made it easy to observe and document, and it continues to be a subject of interest in both scientific and popular contexts. Future research on Betelgeuse is promising, with upcoming missions and studies planned. The James Webb Space Telescope is expected to provide unprecedented views of Betelgeuse and other distant stars. Researchers are keen to observe the star's final stages of evolution and capture the moment of its supernova explosion. Future space missions and observatories will continue to monitor Betelgeuse, providing valuable data that will enhance our understanding of massive stars and inspire future generations of astronomers and space enthusiasts. Although Betelgeuse itself does not have any known exoplanets, studying such massive stars can offer insights into the formation and evolution of planetary systems around similar stars. Understanding the conditions that lead to the formation of exoplanets around massive stars can help scientists compare these systems with those around smaller, less luminous stars like our Sun. Public engagement and education benefit from Betelgeuse's prominence and fascinating characteristics. Astronomy outreach programs use Betelgeuse to illustrate key concepts in stellar physics and the life cycle of stars. Public lectures, planetarium shows, and educational resources often feature Betelgeuse as a prime example of stellar evolution and the dynamic nature of the cosmos. Betelgeuse's potential for a nearby supernova event is a subject of ongoing research and speculation. While the exact timing remains uncertain, its eventual explosion will be a dramatic and visually stunning event, providing valuable data for scientists studying stellar phenomena. Observers on Earth will have the opportunity to witness one of the most significant cosmic events of our time, contributing to our understanding of the universe and its many mysteries. In summary, Betelgeuse is a remarkable star with unique properties that make it a key subject of study in astrophysics. Its immense size, fluctuating brightness, and potential for a supernova event provide valuable insights into the life cycles of massive stars and their impact on the universe. Ongoing research and upcoming missions will continue to reveal new aspects of Betelgeuse, enhancing our knowledge of the cosmos and inspiring future generations of astronomers and space enthusiasts. Betelgeuse, officially designated Betelgeuse, is a fascinating subject in stellar astrophysics due to its complex behavior and impending transformation. The star's profound influence extends beyond mere observation, offering insights into the dynamic processes governing massive stars. Betelgeuse's variability is not just a feature of its brightness but also involves intricate patterns of pulsation and instability. These variations are a result of complex processes within the star's outer layers, where convection cells drive the star's surface motions. The periodic changes in brightness are due to the expansion and contraction of its outer envelope. Such stellar pulsations are thought to be driven by the star's internal changes, where the balance between gravity and thermal pressure is constantly adjusting. The atmosphere of Betelgeuse is significantly influenced by its interactions with its magnetic field. This magnetic field generates large sunspots and starspots, which can be observed through various wavelengths. The star's magnetic field strength, around 1,000 times that of the sun's, impacts the movement of plasma and affects the star's radiation output. The interaction between the magnetic field and the star's plasma creates fascinating phenomena such as stellar flares and coronal mass ejections, which are more pronounced in such massive stars. In terms of stellar evolution, Betelgeuse represents a critical phase. The red supergiant phase occurs after a star has exhausted the hydrogen fuel in its core and has moved beyond the main sequence stage. At this point, the star has begun to fuse heavier elements, leading to its expansion into a supergiant. This phase is relatively short-lived in cosmic terms, lasting only a few million years, compared to the billions of years the star spends in its earlier main sequence stage. Betelgeuse's position in the night sky provides significant clues about its life cycle. The star is situated in the Orion constellation, one of the most recognizable star patterns. Its prominent location makes it an excellent candidate for studying the characteristics of red supergiants. The constellations themselves, including Orion, have been used for millennia by various cultures for navigation and timekeeping, with Betelgeuse serving as a crucial marker in these systems. The impact of Betelgeuse's eventual supernova will have far-reaching implications. A supernova event is not only a spectacular explosion but also a crucial mechanism for dispersing heavy elements into space. These elements, forged in the hearts of stars, contribute to the formation of new stars and planetary systems. The explosion of Betelgeuse will enrich the surrounding interstellar medium with elements such as carbon, oxygen, and iron, which are essential for the development of new solar systems. Betelgeuse's light curve analysis provides scientists with valuable data about the star's internal processes. By examining the variations in brightness, astronomers can infer the star's pulsation periods and map out the internal structure of the star. This data helps in understanding the mechanisms driving the star's variability and its future evolution. Additionally, the study of light curves from Betelgeuse offers insights into the general behavior of red supergiants, improving models of stellar evolution. The historical observations of Betelgeuse contribute to our understanding of its behavior over time. Ancient astronomers noted its brightness and position, and historical records have provided a baseline for comparing modern observations. These historical data points help track changes in the star's brightness and can provide clues about its future behavior. Historical records also highlight how Betelgeuse was a prominent feature in various cultural myths and astronomical practices. Betelgeuse's role in stellar astrophysics extends to its contributions to the study of star formation. By understanding the life cycles of massive stars like Betelgeuse, scientists can better grasp the processes involved in the formation and evolution of stars and galaxies. The insights gained from studying Betelgeuse help refine models of how stars form, live, and die, which in turn improves our understanding of the cosmos. Future observations and missions will continue to enhance our knowledge of Betelgeuse. The advent of next-generation telescopes and observational techniques promises to provide unprecedented views of the star. Instruments like the James Webb Space Telescope, JWST, and future ground-based observatories will offer new data on Betelgeuse's outer layers, magnetic field, and pulsation dynamics. These advancements will be crucial in studying the final stages of Betelgeuse's life cycle and its eventual transition into a supernova. Betelgeuse's effect on its surroundings is another area of interest. The star's intense radiation and stellar winds influence the interstellar medium around it. These interactions can trigger the formation of new stars and influence the distribution of matter in the surrounding space. The shock waves from Betelgeuse's eventual supernova will play a significant role in shaping the nearby interstellar environment, contributing to the ongoing cycle of stellar birth and death. In popular culture, Betelgeuse has made its mark beyond scientific circles. The star has been referenced in literature, films, and television, often as a symbol of the grandeur and mystery of the cosmos. The name Betelgeuse has been popularized by various media, adding a layer of cultural significance to the star. This cultural impact helps engage the public with astronomy and fosters a broader interest in the study of stars and the universe. Educational programs leverage Betelgeuse's characteristics to teach fundamental concepts in astrophysics. By presenting the star's unique properties and evolutionary stage, educators can illustrate complex topics such as stellar evolution, nuclear fusion, and cosmic phenomena. Interactive models and simulations based on Betelgeuse's behavior help students visualize and understand the processes occurring in massive stars. Betelgeuse's observation history provides a rich dataset for researchers. The star has been monitored for centuries, offering a long-term perspective on its variability and changes. This historical data, combined with modern observations, creates a comprehensive picture of Betelgeuse's behavior and evolution. The continuity of observations over time underscores the importance of long-term studies in understanding the dynamic nature of stars. In summary, Betelgeuse is a multifaceted subject in the field of astrophysics. Its size, brightness, and behavior make it a critical focus for understanding the life cycles of massive stars. The star's eventual transformation into a supernova will provide valuable data on stellar evolution and the cosmic processes that shape our universe. As research and technology advance, Betelgeuse will continue to be a key object of study, offering insights into the nature of stars and their impact on the cosmos.